This is the second half of the video set on graphing absolute value functions. And in this video, I'm going to list out the rules that we looked at somewhat informally in the online graphing calculator video, which was the last one. So we looked at shifting the absolute value graph up and down, flipping it over the y and the x-axes, and shrinking it and stretching it vertically and horizontally. And this is what those rules look like. So first of all, I'm just going to write a general function for absolute value, and the a, the b, and the c are all going to correspond to some shift or a flip or a stretch and a shrink. So the a is a stretch or a shrink in the vertical direction. So what that would look like, an example of that, would be, here's my parent graph, y equals the absolute value of x. And if I graphed that, you know from the last two videos, it's going to look something like this. And here, my parent graph is going to be changed. Y equals, let's do 1/2. 1/2 the absolute value of x. And that graph, the graph of that function, is going to be much more open. So it's still going to be a V, but I'm shrinking the vertical axis, which opens up my graph. So this here, that multiplying outside the absolute value bar, in this case, it's my 1/2, that opens or closes the V. And it does that by shrinking or stretching in the vertical direction. So that's one thing that the A does. The A also will make the graph upside down or right side up. So if A is positive, the graph is going to be right side up. And if A is negative, the graph is going to be flipped upside down. So that's what A is doing. A is in charge of opening and closing the V, and it's also in charge of having the V be right side up or upside down if it's positive or negative. Now let's look at the C. We won't do this quite in order. We'll look at C next. Let's take a look at what C is doing. So C is going to be the shift up and down. So C shifts up and down. And I'll give you an example of that. So here's my example. And I'm still going to use that same parent graph, y equals absolute value of x. But this time, I have y equals the absolute value of x plus 3. And that graph is still going to be a V, but it's going to start up 3 on the y-axis. So that doesn't look very V-like. Cool. I lost my graph here. There we go. Sorry about that. Just redraw it in another space. 1, 2, 3. So it's still a V, but it's shifted up 3 in the vertical direction. And of course, if it's subtracting, so here's another example. Y equals the absolute value of x minus 2. That's going to move my V down 2. So down 2. Down 2 in the vertical direction. So the adding 3 moves the graph up, and the subtracting 2 moves the graph down. So that takes care of the C. The C is shifting things up and down. The A is stretching or shrinking vertically, and it's in charge of whether the graph is right side up or upside down. Upside down if it's negative, right side up if it's positive. We still have to figure out about the B, though. So what is this B doing? And whatever's inside the absolute value bar, so whatever number you're adding or subtracting, is moving things left to right. So let's do one for the B. So the B moves the graph left and right. Well, really, it's left or right. It's one or the other. And we've seen that when you're adding or subtracting something to the x, inside parentheses, if it's a parabola, in this case it's inside the absolute value bars, it has the opposite effect of what you might think. So if you are adding, so I'll give you an example of that one, y equals the absolute value of x plus 2. We would probably think, oh, it's going to be moving to the right 2, but in fact, it's moving everything to the left 2. So here's what the graph looks like. 1, 2, so there's a negative 2. So it goes in the opposite direction of what it's looking like. Here it's moving to the left 2. And likewise, if I were going to subtract something from the x, subtract inside the absolute value bar. So y equals the absolute value of x minus 1. That graph is going to look shifted to the right. So here's 1, and here's my absolute value graph. So if we're subtracting, we're actually going to be moving to the right, the opposite of what you might think. So let me just zoom out here a little bit so we can see all these rules at once. Oops, I need to zoom out a little bit more. There we go. So the A in yellow is in charge of shrinking and stretching, and also whether it's going to be upside down or right side up. If it's negative, it's upside down. You might also see just a negative sign. So here's an example of that. Y equals a negative absolute value of x. That's going to be an upside down V. The B moves the graph to the left or the right, and it's always the opposite of what you think. If it's adding, you're going to be moving it to the left. If you're subtracting, you're going to be moving it to the right. And the C shifts the entire graph up and down, and that's sort of what you think it might be. That's outside the absolute value bars, whatever you're adding or subtracting outside. And that's going to shift up if you're adding and move down, shift down if you're subtracting. So in the next video, I'll do a couple from your homework with you so you can see these rules in action. See you in the next video.